Hello everyone, here we are going to continue with exercise 9b of the chapter triangles, which was based on congruency of triangle. We have already did till question number 7 from this exercise. Now let's start with question number 8. Now here in this question we are having two triangles ABC and PQR, in which this AD is median of the triangle ABC and PS is the median of the triangle PQR. It has also been given to us that AB is equals to PQ. This AD is equals to PS and this BC as a whole is equals to QR. Now we have to prove the triangle ABC is congruent to triangle PQR. Now to prove these two triangles congruent, we need two sides. So we can use this side equals to this one and this side equals to this one. Now we need the third side or one angle. So for the third side we are having AC and PR. We aren't given any hint or any relation for these two sides. So we are left with the angle. Now we need angle B equals to angle Q. But this is also not been given to us. So very first of all we have to try to prove these two angles equal. And that we are going to do by proving this triangle ABD congruent to triangle PQS. And this can be done by using this side AB equals to PQ, AD equals to PS, and this BD will become equals to QR because this BC equals to QR and this BD and QS both are half of the whole. So here in triangle ABD and PQS, AB equals to PQ given, AD equals to PS again given. Then we have BC equals to QR given to us, but BC and QR as a whole is not a part of this triangle, neither of this triangle. So we are going to take the half of BC and half of QR. And if the whole is equal, then half will also equal. So half of BC equals to half of QR. Now we see that AD and PS both are the medians of the triangle. So this BD will become equals to QS. Therefore BD equals to QS as AD and PS are medians of the respective triangles. Now to prove these two triangles congruent, we have used all the three sides. So triangle ABD is congruent to triangle PQS by SSS. Now, as this both triangles are congruent, then this angle will become equals to this one by CPCT. Therefore, angle B equals to angle Q by CPCT. Now we can prove the triangle ABC congruent to triangle PQR. Therefore, in triangle ABC and PQR, AB equals to PQ given, BC equals to QR again given, and angle B equals to angle Q proved above. Now to prove these triangles congruent, we have used the side, this angle, then this side. So it is SAS. Therefore, triangle ABC is congruent to PQR by SAS. Hence, proved. Now let's move to question number 9. Here in this question, we have been given with this figure. And in this figure, this AP is parallel to QB as well as it is equals to this one. Now we have to prove that triangle AOP is congruent to triangle BOQ. And also that AB and PQ bisect each other. Now very first of all, let's prove the triangle AOP congruent to triangle BOQ. Here AP will be equals to BQ as given to us. Then this angle A will be equals to angle B as interior alternate angles. Also angle P will be equals to angle Q by interior alternate angles. Now to prove these two triangles congruent, we have used this angle, this side, then this angle. So it is ASA. Therefore, we have got the triangle AOP congruent to triangle BOQ by ASA. Now to prove these two sides bisect each other, we are going to prove that AO equals to BO by CPCT as well as PO equals to QO by CPCT. Now as this side equals to this one and this is equals to this one, therefore they both bisect each other. And here we get AB and PQ bisects each other. Hence, proved. Now let's see question number 10. Here in this question we are having this figure, and in this figure we have been given with AO equals to CO and AB equals to BC. Now we have to prove this angle AOB is of 90 degree. So for this, first of all, we have to prove these two triangles congruent. So in triangle AOB and COB, AB equals to CB given to us, then AO equals to CO again given to us, then BO equals to BO common. Now to prove these two triangles congruent, we have used all the three sides, this and this one. So triangle AOB is congruent to triangle COB by SSS. Now as these two triangles are congruent, then this angle will be equals to this one. Therefore, angle AOB equals to angle COB by CPCT. Now the sum of these two angles will be equals to 180 degree as they are linear pair. And from this relation, let this one be equation number 1. From here we can conclude that the twice of angle AOB equals to 180 degree. And as twice of angle AOB is 180 degree, therefore angle AOB will be equals to 180 upon 2, that is 90 degree. Hence proved. Now after this, we have to prove the triangle AOD congruent to triangle COD. So in triangle AOD and COD, AO equals to CO given, OD equals to OD common, angle AOD equals to angle COD as they both are of 90 degree each. Now to prove these two triangles congruent, we have used this side, this angle, and then this side. So it is SAS. Therefore triangle AOD is congruent to triangle COD by SAS, and this AD equals to CD by CPCT. Therefore AD equals to CD by CPCT, hence proved. Now let's move to question number 11. Here in this question we are having this figure ABC in which this AB equals to AC. We have to prove that AM is equals to AN. Here we have got AB equals to AC and BM equals to CN in a given portion. Let this one be equation number 1 and this one be equation number 2. And on subtracting equation number 2 from equation number 1, we get AB minus BM equals to AC minus CN. Now AB minus BM will be AM and AC minus CN will be AN. Therefore we get AM equals to AN. Now this was your first part. Now in the second part, we have to prove this triangle AMC is congruent to triangle ANB. So in triangle AMC and ANB, this angle A is common in both of the triangles. So angle A equals to angle A common. And this AM equals to AN just proved. And AC will be equals to AB. This was given to us. Now to prove these two triangles congruent, we have used this side, this angle, and this whole side. So it is SAS. Therefore, triangle AMC is congruent to triangle ANB by SAS. Now this BN is equals to CM by CPCT as the corresponding parts of these two triangles. So here we got CM equals to BN by CPCT. So here we completed our second part and third part. Now let's move to the fourth part. Here we have to prove that BMC is congruent to triangle CNB. So in triangle BMC and CNB, CN equals to BM given to us, BC equals to CB common, and CM equals to BN proved above. Now to prove these two triangles congruent, we have used this side, and this one. Therefore triangle BMC is congruent to triangle CNB by triple S, hence proved. Now let's move to question number 12. Here we are having the triangle ABC in which CE and AD are perpendicular from the vertex A and C to the opposite side BC and AB respectively. Now we have to prove this AD is equals to C. The side AD equals to C. For that we are going to prove the triangle ABD congruent to triangle CBE. So in triangle ABD and CBE, we have AB equals to CB given to us. Then angle B equals to angle B common in both our triangle. Then angle ADB equals to angle CEB 90 degree each. To prove these two triangles congruent, we have used this angle, and this whole side. So it is AAS. Therefore triangle ABD is congruent to triangle CBE by AAS, and AD will be equals to CE by CPCT. Therefore AD equals to CE by CPCT. Hence proved. Now let's see question number 13. Here in this question we are having a parallelogram PQRS in which L and M are the points on the PQ and RS respectively. Then we have been given that PL is equals to RM, and we have to prove this LM and QS bisects each other. Very first of all, let this one be O. Now to prove these two triangles congruent, we can use this angle equals to this one as they are interior alternate angles, and this angle will be equals to this one again by interior alternate angles as the opposite sides of parallelogram are parallel to each other. Now the third thing is that we need one side. So we have to first of all show that this LQ is equals to MS, because this PQ will be equals to RS and this PL is equals to MR given to us. And after subtracting this equal portion from the equal sides, we will be getting this LQ equals to MS. Here we get PQ equals to RS as opposite sides of parallelogram and PL equals to RM given to us. Let this one be equation number 1 and this one be equation number 2. And on subtracting equation number 2 from equation number 1, we get PQ minus PL equals to RS minus LM. And this PQ minus PL will be equals to LQ and RS minus RM will be equals to MS. So LQ equals to MS. Now we are going to take these two triangles. So here we have got LQO and triangle MSO. Now this angle will be equals to this one. Let this one be angle number 1 and this one be angle number 2. So angle 1 equals to angle 2, interior alternate angles. Now we can use either this equals to this one or this equals to this one, as this both are vertically opposite angles. So let this one only, LOQ equals to angle MOS. So here we get angle LOQ equals to angle MOS by vertically opposite angles. And the side LQ equals to MS is proved above. Therefore, these two triangles are congruent as we have used this angle and this side. So AAS. Therefore, triangle LQO is congruent to triangle MSO by AAS. And this LO will be equals to MO by CPCT. Also, this QO will be equals to SO by CPCT. Now, as this LO is equals to MO and QO equals to SO, therefore LM and QS bisects each other. Here we get LM and QS bisect each other. Hence, proved. Now let's see question number 14. Here in this question, we are having a triangle ABC in which AC is produced to R and this CR is equals to the side BP of the triangle QBP. And in this one, QP is parallel to AC. Now we have to prove that PC and QR both bisects each other. For that, we are going to prove these two triangles congruent. In proving these two triangles congruent, as we are having this line is parallel to this one, we use this angle equals to this one as interior alternate angle, this angle equals to this one as vertically opposite angle. But we aren't having any side because these two sides is to be proved only. We are left with only this side and this one. So we have to prove these two sides equal. And in this triangle, this BP equals to CR. So we are going to try to prove this BP equals to QP. For that, this angle Q will be equals to this one as corresponding angles, and also this angle will be equals to this one as corresponding angles. And as this ABC is a equilateral triangle and this angle equals to 60 degrees, so this will also 60 degrees. Similarly, this is 60 degree, so this will also 60 degree, and hence this is also 60 degree of the triangle ABC. Now we are having all the angles 60 degree, therefore this is also a equilateral triangle and hence all of the sides will be equal. So this will be equals to this one and then this will be equals to this one. Here we get angle BQP, this one equals to angle BAC, corresponding angles, and this will be equals to 60 degree. Now similarly, BPQ equals to angle BCA, that is also of 60 degree. Now in triangle BPQ, we are having all the angles of 60 degree. Therefore, this is an equilateral triangle. And as the triangle BPQ is an equilateral triangle, therefore BP will be equals to QP at the sides of equilateral triangle. Now BP equals to CR is been given to us. From these two equations, we can conclude that QP equals to CR. Now we can prove these two triangles congruent. So in triangle PQM and CRM. So from these two triangles, we can use this QP equals to CR proved above and this angle equals to this one by interior alternate angle. Let this one be angle number 1 and this one be angle number 2. So angle 1 equals to angle 2 interior alternate angles. And this angle equals to this one vertically opposite angles. That is angle PMQ equals to angle CMR, vertically opposite angles. Now to prove these two triangles congruent, we have used this angle and this side. So it is AAS. Therefore, triangle PQM is congruent to triangle CRM by AAS. Then we can prove this PM equals to CM by CPCT and similarly QM equals to RM by CPCT. And as this side equals to this one and this is equals to this one, therefore PC and QR bisects each other. Here we get PC and QR bisect each other. Hence proved. That's all from this video. Thank you.